Why do people go bald?
Why are baboons' bums red?
What's a light year? Why do leaves go brown in the autumn? Why do monkeys like bananas? Why do some things glow in the dark? Why do animals not understand you? Why do my receipts fade after a year?
Don't know the answer? Ask the Naked Scientists.
Hello, welcome to this week's edition of Ask the Naked Scientists with Chris Smith, Dave Ansell, and with me, Matt Jamison. Now, Fleetwood in Suffolk would like to know what causes phosphorescence on rivers and seas.
OK, well, if you go down to the beach in summertime and do what I did when I was on my honeymoon, I was in the Mediterranean and I was walking on this beautiful moonlit beach. It was a very romantic evening. We'd been out to dinner. I'd been married 3 days and it was a lovely hot night and we thought, let's go in the sea. So we ran down the beach and we had some clothes on, didn't completely strip off. We went into the sea and as I was swimming around, I noticed that I was producing a sort of phosphorescent bow wave. So literally the water coming over my body was glowing bright green. And this is a phenomenon I'd seen a few times because I used to spend quite a lot of time going sailing and diving and things. And I said to my wife, hey, look at this, I'll show you something really interesting. And I was waving my hands backwards and forwards in the water to excite the water to make all this phosphorescence. And I watched the most expensive display of phosphorescence you've ever seen in your life because I watched my wedding ring go down in a trail of this stuff down to the bottom of the sea. And of course I couldn't find it. And the people on the beach who'd turned up by then thought after that my wife was trying to drown me because there was this person out in the sea holding down this guy and standing on him underwater because this was actually me on the seafloor going around with my fingers trying to find my wedding ring was. But the reason my wedding ring went down in this beautiful trail of phosphorescence is because seawater and river water is crammed with microorganisms. If you were to take a sample of the seawater and put it under a microscope, you'd see that there are lots of bacteria there. Most of them are completely harmless to us, but as well as the bacteria, there are other tiny organisms. There are various algae, these are single-celled plants, and other things like viruses. But some of these organisms actually have light-making machinery. In the same way that a firefly, or a glowworm, wants to attract a mate, they can turn on this particular chemical reaction in parts of their body which gives out light. That's exactly what these microorganisms can do. It's actually an enzyme and it's called luciferase, after Lucifer's, the name for the devil, fiery, and also Lucifer, the first type of match, the first commercially produced match were called lucifers. And this enzyme breaks down a chemical compound which is actually part of the waste products of metabolism. It's called luciferin. And the enzyme breaks this down using some oxygen and another energy molecule in cells called ATP. And when you put all these things together, you get green or bluey light. And for some reason, and I don't know exactly why, but when you excite these organisms by agitating the water, for example, they flash and they give up these bursts of light. This is something that you can see, and often people see this when you go rowing. If you go out at night and row a small boat across, say, the sea, you'll see when the oar dips in, you'll get a flash of light. So that's why you see this phosphorescence, and it tends to be more vivid in the summertime because the water temperature is higher, and because this is a chemical reaction, chemical reactions go faster the higher the temperature is. So for every about 10-degree rise in temperature, you get a doubling of the rate of a reaction. So when the sea temperature or river temperature goes up, you get more of this light produced, so you're more likely to notice it when the weather's warm in the summer.
Yeah, the other reason why it's probably more common in the summer is it's actually a little tiny algae. They're a type of algae called diatoms. They've got little skeletons made out of silica, like little bits of rock skeletons. And so because it's an algae, it's a plant, so it's growing from sunlight. So in the summer, there's going to be a lot more algae around because it's got more sunlight to grow on than in the winter when there's not enough light for it to grow very well.
Fascinating stuff. Anyway, you've got a question for Dr. Dave, haven't you?
You've got an email here which I thought would probably be up Dave Street. It's been presented by Terry, and he says, my question's not so much about the age of the universe, but how we can look back to the beginning of the universe. And he says, why is it that I keep hearing people ask, why can we see stars or early vestiges of the universe going back 13.5 billion years old? I don't understand how light can last 13.5 billion years. Why is it still travelling towards us? If it came from the earliest universe, surely it would have gone past a long time ago.
Basically, the universe is a very, very, very big place. Light can spend 15 billion years travelling across it and keep on going in a straight line. If light carries on going in a straight line, as long as it doesn't hit anything, there's nothing to stop it. It's going to keep on going and going and going for as far as we know for an infinite amount of time. time. So basically, because the universe is very, very big, it's got quite a lot of stuff in it, but compared to how big it is, there's not very much stuff. So light can spend 13, 14, 15 billion, probably about 13 billion years going in a straight line and not hit anything. And because it's not hit anything, it'll just keep on going. And the first thing it hits is us, and then our telescope, then we can see it.
I suppose the one sort of spin-off of that, Dave, is what's called cosmic background radiation, isn't it? Where people were able to get some inkling into the existence of the Big Bang because they were able to detect what amounts to radio interference and relate that to the radio waves and the big pulses of radiation that must have come when the universe first popped into existence about 14 billion years ago with the Big Bang.
Yeah, it's definitely several million years after the Big Bang. What you can see, the cosmic background radiation, if you look in any direction you like, you see a sort of faint glow. It's actually in the microwave part of the spectrum. Originally, this was really powerful gamma rays. It's what happens when all of the universe, it started off as a plasma. That means that all the centres of the atoms and the electrons were flying about independently. At that point, it was opaque. You can't see through it. Then slowly all the electrons got caught by the atoms and turned into normal the centres of atoms. They turned into normal atoms. Then it becomes transparent, and that gives out a huge amount of energy as a form of light. And then we can still see that light having travelled all the way across the universe from very, very close to the beginning as this cosmic microwave background radiation.
Cosmic microwave background radiation.
Indeed.
And the really snazzy bit, Matt, is that the reason it's stretched and it's no longer gamma rays, it's now microwaves, and gamma rays have a very short wavelength and microwaves have a very long wavelength, is because the universe has expanded. It's got bigger. And so by stretching out the radiation, it's sort of gone from very, very compact short waves into very, very big waves, and that's why they're now microwaves rather than gamma rays.
I'd love to be in the pub with you two. Hannah in Cottenham, good evening to you.
Hi.
How are you?
I'm fine, how are you?
Excellent, not too bad, thank you. You got a question for Dr. Chris?
Yes, I was just wondering, can you cry underwater?
There's no reason why not, Hannah. You certainly can. The reason you cry, well, variety of reasons why you would cry, but the crying reflex is the production of fluid from your lacrimal gland. Lacrimo in Latin means I cry, and that's why it's called the lacrimal gland, because medics are obsessed with Latin. But the lacrimal gland sits on the outer part of your eye, and it's got nerve supply from the brainstem running into it. And so when your emotions, whatever they are, or chemical stimuli to the eye trigger the lacrimal gland to get active, it squeezes the tears down the duct from that gland into the corner of your eye. They then run across the eye, and normally what happens is that they go towards the middle centre of your eye, so in other words the bottom of your eyelid towards your nose, and if you look on the lower eyelid you'll see there's a tiny black dot there. That's called a punctum, and that's like your drain pipe or the plug hole for your eye, and normally the tears would go down there and it runs into your nose, and that's why if you cry for any reason you want to blow your nose, you get a runny nose because the tears all end up in your nose. Now, if you go underwater, of course, then there's no reason for the tears to want to flow down that duct anymore because, well, part of the reason is that there's loads of water, and if you've got your eyes open underwater, then the tears will just go into the surrounding water. But if you could go underwater for long enough and cry underwater, there's no reason why it wouldn't happen. In fact, going into water does irritate the eye very slightly, and it will make more tears be produced. So I suspect, yes, you would definitely class that as crying underwater.
Thank you, Hannah, for the call. And, of course, when you're faced by quite heavy winds and things like that, like a lot of people have been today, that makes tears in your eyes as well, doesn't it?
It certainly does, and the front of the eye, the part of the eye called the cornea, which is the very front of the eye where you would, for instance, put your contact lens if you wear contact lenses, that has one of the densest supplies of pain nerve fibres in the body. So injury to the cornea is amongst the most painful sensation that you can experience, even more painful than childbirth, he says, as a bloke. But the point is that anything that irritates the eye stimulates those nerve fibres, and they are wired up via the central nervous system in the part of the brain called the brainstem, back to the lacrimal gland. So in other words, there's a sort of, in the same way as you do a knee jerk, if you tap your knee, your leg jerks, there's a similar reaction that happens with tear production in the eye, because the eye assumes that any damage or irritation to the front of the eye is caused by something getting into the eye that shouldn't be there, and it produces more tears to flush it out. And in the tears, there's isotonic fluids. So these are fluids which have the same concentration as body fluid, so they're very cleansing to the eye. They're very sort of calming, and they are capable of relieving itch and irritation on the eye. They also contain various enzymes, including one called lysozyme, and this can bust open bacteria. So if there's any infection on the eye, it can break it apart. And there's also other things called antibodies. So these are small proteins shaped like the letter Y that can lock onto things like viruses and bacteria and neutralise them. So tears are actually very important, and tears are very, very similar in their composition to saliva, the stuff that comes out of your mouth. And they're all made from the bloodstream. So blood flowing into the gland gets turned into saliva or tears by filtering the blood, keeping the cells back, and just letting the fluid go out into the gland ducts, which is what ends up in your eye.
Fascinating stuff. Got a question here for Dr. Dave. It says, we know about plants up in space millions of miles away, but what about directly under the Earth? It comes in from Mike.
Yeah, I mean, people have looked for plants and life outside the Earth. They haven't actually found any yet. They've found all sorts of... They've found life quite deep under the Earth by looking in boreholes and things. They've found bacteria down sort of 3, 4, 5 kilometres down through solid rock. They've even found some bacteria. There's a story recently. They've found some bacteria which have been living, as far as they could tell, in a piece of rock for the last... Chris might remember, about several million years, Chris?
Yeah, I think what Dave's getting at is there was a wonderful story from Johannesburg, or near Johannesburg in South Africa, where they have some of the deepest mines in the whole world. These are gold mines, and they go down perhaps 3 or 4 kilometres underground. And in fact, it gets very hot down there. And researchers from Indiana, in America, University of Indiana, have teamed up with the miners in Johannesburg because these researchers in America are very interested in types of bacteria that can tolerate extreme conditions along the lines of what Dave was just saying. And in this mine, in recent years, the miners hacked into a new patch of rock and suddenly all this water came shooting out. And when they analysed the composition of this water, they realised that it was millions of years old. In other words, the water had been locked away underground without any contact with the outside world for between 16 and 40 million years. And we know that because you can analyse what's called the isotopic chemical composition of the water to date it. You can work out its rough age. Now, this means there's been no input from the sun or any other life on Earth to that water. So it really was a shock to the researchers when they analysed it and found that it was thriving and thronging with life. It was full of bacteria. And when they looked at the metabolism of these bacteria, they found that it was unlike anything else on Earth, with the exception of bacteria that live around those very deep vents that are on the mid-ocean ridges at the bottom of the sea. And when they analysed very carefully what these bacteria were doing, it turned out they were living on radiation. And in these very deep rocks, 3 kilometres underground, there's a lot of uranium. Well, relatively large amounts of uranium. And when the uranium breaks down radioactively, it spits out something called an alpha particle, which is a helium nucleus. It's 2 protons and 2 neutrons stuck together. These are very high-energy particles, and when they go through things like water, they collide with them and rip them to pieces. And one of the things that was happening in this mine water was the alpha particles were pulling water molecules to pieces and producing hydroxyl radicals and other hydrogen ions. And these radicals were reacting with minerals in the rock, and there's a lot of fool's gold, which is pyrites, in the rock alongside normal gold. And pyrites is iron sulfide, and so they were liberating sulfur from the rock in a form that these bacteria could eat. So these bacteria, for between 16 and 40 million years, have been living underground, powered by nothing more than just radiation. And why scientists are excited about that is that means that the same process, if life has evolved on places like Mars or other planets in our solar system, or even in other solar systems, there could well be bacteria flourishing in places that you would never think possible, just powered by something like radiation.
Crikey. Eben in Kent would like to know about recurrent corneal erosion. Can you treat it or make it less painful?
Okay, well, there's a number of reasons why you can have these. The corneal ulcers are incredibly painful, and this is where you have damage to the front surface of the eye, and it exposes the very dense meshwork of very tiny nerve fibres. There are some of the smallest nerve fibres in the body are in the eye. They're a class of nerve fibres called C fibres, and they are less than 1 micron, so less than 1,000th of a millimetre across. They're just sort of naked nerve endings. And obviously if you irritate the tissue, it irritates those nerves. Now, there are certain reasons why you can get an ulcer in the eye. The commonest reason is actually associated with contact lenses, and people who don't practice adequate hygiene with their contact lenses can often get them infected with an amoeba, which is present in water supplies. In drinking water in houses, there's something called acanthamoeba, and it's pretty much in everyone's water tank. And if you wash your contact lens case with just fresh tap water, it can become contaminated with these amoebae, which are really quite hardy creatures. And what this means is that they can get onto the surface of your contact lens, and then when you put it into your eye, you have them in close apposition to your cornea for a long time, and they can burrow in. And then they start this ulcer forming, and this can become incredibly painful and very, very sore. And it can also lead to blindness, because the only way to get rid of it is very often to actually remove the damaged bit of tissue and also put the person on drugs to treat the infection, and then hope that the cornea can heal itself back up again without scarring, because of course if it forms scar tissue, this will obstruct the path of light into the eye, and you can end up with blurred vision. Now, other reasons why you can get corneal ulcers include herpes simplex virus. This is the cold sore virus. Most people associate this with getting cold sores, these unsightly and painful lesions that you get around your mouth. They can occur periodically. About 80% of the population carry the virus in their nervous system, and about 15% of people have regular reactivations or recurrences of the virus coming back out of the nervous system to produce these. But occasionally the virus can get into the eye, and it can come back out of the nerve fibres that supply the front of the eye, and it causes the equivalent of a cold sore, but on the front of your eye. And this is incredibly painful, and if it's allowed to go on for long enough, it can lead to scarring, and it can lead to blindness, and this is called herpes keratitis. So it's worth excluding herpes keratitis as a cause of recurrent corneal problems, and it might be worth taking a drug which can stop herpes viruses, which is called acyclovir. If people have used Zovirax or one of these proprietary ointments that you can put on a cold sore, that's got acyclovir in it. It's a drug that stops just herpes viruses, very effective. And sometimes if you have recurrent herpes problems, you can get this stuff in tablet form, and it deactivates the virus and stops it causing problems.
Excellent answer. Thank you for that. We've got Tony in Westcliff. Would like to know if everything, no matter what size, can have gravity applied to it. I think this one for Dr. Dave. How big or small would something need to be in space to be affected by a gravitational pull of a planet?
Basically, as far as we know, the way Einstein, he's invented relativity, and what he said was that what gravity actually does is it bends space. So he thinks of gravity as it bends space. So it sort of bends space into a hot. If a big planet's sitting there, it bends space into sort of like a dip, and everything falls into that dip. And so even light will be affected by light's the smallest and lightest particle we know of. As far as we know, it has no mass itself if it's stationary, and even light will be affected by gravity. Astronomers have used this to see the furthest we've seen out into the universe so far we've managed to see is by using this effect.
But why should light be affected by gravity, Dave, if it doesn't have any weight or mass?
Because the universe is bent, curved. It's a bit like... so if you have a curved piece of universe, it's a bit like a lens.
Do you get those in B&Q? I'll have one curved lump of universe, please.
Or you need something heavy. Everything curves the universe to a certain extent. I mean, you and I do to a very minute extent, so tiny you couldn't possibly measure it. But if you're looking at something big, I mean, you can notice it just from the sun. So the sun will act like a very, very weak lens and bend light from behind it. Sometimes you can see stars, which you shouldn't be able to, just when they're very close to the surface of the sun. And also much heavier things like galaxies and or black holes can really bend light. So if you look right off into the thousands of light years away and you see a big heavy galaxy, and sometimes behind that galaxy you can see around the edge of it you see bits of another galaxy which is another few thousand light years beyond that, but it's being magnified by the lens from this from the front galaxy, and so you can see several thousand light years further on as if there was a huge lens in space, and we can see a lot further out than we would do otherwise.
We're back with the Naked Scientist. We've got a question from Gary, which we're going to put Chris's way. I think I heard they found a cure or fix for tinnitus. Is that true? That comes in from Gary, Dr. Chris.
Okay, well, tinnitus is this really unpleasant ringing in the ears, and it tends to happen as you get older. So older people tend to have it more than younger people, and that's usually because hearing loss is more common in older age. And what we know tends to trigger tinnitus is exposure to loud noises. So if you've worked in a very loud environment, or for instance you've been working on the roads and using one of those road drills without proper ear defenders, or you've been a miner and using a drill underground, or just doing any old sort of work which involves exposure to loud repetitive sounds, what this seems to do is to cause damage to the part of the ear that coordinates turning that particular sound frequency into nerve impulses. Now, the way it works is that you have this structure called the cochlea in your inner ear, and this is an array of nerve fibres called hair cells, and according to, well, the way it works is that you have this long array of these hair cells, and different parts of the cochlea vibrate better at different frequencies, and they pass those vibrations onto those cells that then turn them into nerve impulses that then the brain decodes, and it turns that into sound that we hear consciously. Now, when you get tinnitus, it seems like some of those hair cells corresponding to certain frequencies of sounds are killed. So we know that long-term exposure to very loud or repetitively loud sounds seems to be bad for these cells, and it causes them to die. Now, when the brain is deprived of the input from those cells, it seems as though the brain starts to invent sound, because it's almost like if you can't hear something on your radio, you might turn the dial up on the volume very, very loud. The idea being that you think, well, if I turn it up a bit louder, I might hear something. And what you will get is a lot of background hiss, the tss noise that you get. And this is what we think is going on in the part of the brain that presents the sounds you're hearing to your consciousness. So it's almost like phantom limb syndrome, where you amputate a leg and you get terrific pain coming from the leg you no longer have. We think of tinnitus as the sort of similar sound phenomenon equivalent to that happening up in the brain. In terms of treating it, it's very, very difficult to treat, because it's not actually a physical symptom caused by something you can operate on and remove. So it's not like you can go in and remove the thing that's triggering it, because it's your brain itself that seems to be creating these sounds, or the experience of these sounds. There are some drugs that people have tried which do in some people have limited success, but it is very distracting, and people find that sometimes just trying to stop the problem getting any worse by minimising exposure to loud noises can be the best defence, actually. But it's a very annoying condition, and I think some of the great composers in their time have suffered from it, and people who play in orchestras can even get this, and they tend to have fairly defined hearing loss in the frequency of their ears corresponding to the instruments that sit right behind them. So the guys in the woodwind who have the trumpets blasting into the back of their heads can get quite a selective hearing loss at frequencies corresponding to those most often played by trumpet players when they get overzealous in nice loud bits of Beethoven or something.
Bob in Dagenham, here's one for Dave, I think. Why are all the planets round? What makes them like this?
Okay, so it's basically gravity. Basically anything with mass, anything which is heavy, it will attract anything else with mass. So if you had two big weights in space with nothing else around them, they'd sort of try and get as close to each other as possible. And then if you had another one, it would try and get as close to all the other ones as possible, and slowly get closer and closer and closer. And then if you imagine, instead of with weights, if you imagine a liquid, the way you can get the liquid as close to each bit of the liquid as close to all the other bits of liquid as possible is a sphere. Because a sphere's got the least surface and everything is as close as you can possibly get. And although it might not seem that way, once you get to a really, really big planet, rock basically behaves like a liquid over millions of years. The continents will move around the place, and if you crush a rock, two big continental plates together, they'll kind of squidge up and squidge around the place and basically flow like a liquid. So if it's anything the size of a planet, basically the rock in it will just flow until it's all as close as possible to all the other bits of rock in the planet, which is basically a sphere, give or take. And the bigger the planet is, the stronger that effect is. So if you look at sort of small asteroids, they're only roughly a sphere. They can be kind of potato-shaped or dumbbell-shaped, or very roughly a sphere. Once you sort of get up to beyond a few hundred kilometres, 1,000 kilometres, then it's very, very difficult for anything to support anything which isn't a sphere.
That's a very good answer, and we've got a final question here, which either of you can take, and I think you'll both give it your best and probably give us a decent sort of explanation. Why, when I hear some tunes, do they seem to stay in my head for days, yet others don't? That's from Janet in Northampton. Dr. Chris, we'll start with you.
It's called an earworm. That's the technical term, is an earworm, and no one knows exactly why this happens, but it's what's called an auditory hallucination. Now, it's very interesting. Scientists have actually pinned down the bit of the brain that corresponds to this happening, and they did a very elegant series of studies on this about 3 or 4 years ago. What they did was to put people in a brain scanner and play them pieces of music. And some of the music they knew very well, and some of the music they didn't know at all. And they compared the brain scans when they played people these bits of music, first of all. And then what they did was something very cunning. They started introducing patches of silence into the music. So if you're, say, listening to the bit of Snow Patrol, what you would end up with is you'd be humming along with it in your head, because all of us, when we hear a piece of music, we're predicting what's coming next, because we know the tune, and that's why we like it, because we've come acquainted with what comes next, and we like the reward that goes with being able to predict what's going to happen next. When these patches of silence cropped up, people's brains, of course, carried on humming the tune internally, even though there was no music. So what the researchers could do is to see how the brain scan changed between when the music was coming in from outside compared with when the brain was inventing it itself, and this enabled them to pin down the bit of the brain that's concerned with inventing these tunes in your head. And it's the same bit of brain when you have these earworms, when you have Kylie Minogue, Can't Get You Out of My Head, going round in your head incessantly.
That was a clever title song, wasn't it?
Well, it very, and it's true, because I ended up with it as one of these earworms. But when I asked someone recently what the best way to get rid of these things is, he said, well, the answer's simple. There is a cure for an earworm, and how you get rid of it. He says you have to find another one. So the only answer is, unfortunately, the only cure for a tune that keeps going around your head is to find another tune that goes around your head even better. It's probably because we like learning things, and human beings are very good at practicing. And when you rehearse things, part of the rehearsal process is the brain rehearsing the pattern of neural activity that enables you to think or reproduce memories. And the same goes for sounds and tunes. And some tunes are just very catchy because they produce certain patterns of activity which your brain seems to like. And so the only way to get rid of it really is to wait till it sort of extinguishes itself, or replace it with an even more catchy piece of music.
Anything else?
I mean, I think it's definitely to do with how much you listen to music, because me being a very strange 6-year-old, I decided I hated music, and I never really got over that till I was about 18, when I discovered I loved dancing. And so I never get earworms if I'm just sitting around not doing anything. But if I'm doing something repetitive, if I'm walking, I'll get a tune in my head, because I've only ever listened to music when I'm dancing. And I'm doing something kind of physical.
So it can relate to certain experiences and things that you've done in the past.
I think it's probably, I think if something's subconscious is triggering it.
That's it for this week. Thanks for listening. Remember, you can send The Naked Scientists your questions by email. chris@thenakedscientists.com is the address to write to. And if you want to find out more about The Naked Scientists, then drop by our website, nakedscientists.com.
The Naked Scientists are sponsored by the Wellcome Trust, the EPSRC and UK Fast. For more information, look us up online at nakedscientists.com.